Hi, my name is Erin McDonald. I'm an assistant professor in mechanical engineering at Stanford University. Today I'm going to tell you about a couple projects going on in my lab that are supported by NSF. The name of my lab is the IRIS Design Lab. That's Interdisciplinary Research in Sustainable Design. Our lab takes a human-centered design approach, which means that we are trying to empathize with the user, stakeholders, and other members of a design system when we design products and technologies. Empathy can be divided into two different types of empathy. There's cognitive or perspective-taking empathy and emotional and affective empathy. These are distinguished both neurally and clinically. Cognitive empathy in design research draws from behavioral psychology, decision-making, and cognitive science. Quantified cognitive empathy allows us to include human-centered design in mathematical models of products and statistically test hypotheses in test versus control experiments. By injecting this perspective-taking into models, we can represent how people will prefer and react to cognitively complex product purchase, use, and involvement decisions. Decisions about sustainable products and technologies are such cognitively complex decisions. People need to weigh distant concerns along with everyday concerns during product interaction. Perhaps you've heard of the three pillars of sustainable design: economic, societal, and environmental concerns. Sometimes these are also called the 3 Ps: people, profit, and planet. When it comes to quantifying these concerns, engineers have a really good handle on how to quantify environmental concerns using tools such as life cycle analysis. They aren't so good at quantifying economic concerns. Mainly they focus on profit. But when it comes to societal or human-centered concerns, things are still very vague. Often the discussions become philosophical or involve ethics and implications for the developing world. But what about user desires? Those are part of what should be quantified in this third pillar of sustainable. The research we will review today uses a technique called quantified cognitive empathy, where our researchers in the IRIS Design Lab use models and experiments to put numbers with user concerns. Then this pillar of engineering can be merged with the economic and environmental concerns, where the numbers can be traded off and weighed. If you think of this as a surface rather than 3 separate pillars, you can find the area of good design that can satisfy users, bring profit to the company, and be healthier for the planet. Now we'll have Mike Erickson talk about one such project.
Hello, I am Michael Erickson, a graduate researcher in the IRIS Design Lab. The goal of the Consideration, Design, and Energy Policy Grant is to integrate one important non-compensatory decision process, consumer consideration, into enterprise-level engineering design optimization and transportation energy policy analysis. To this end, 3 specific objectives have been identified. First, characterize the impact of consumer consideration behavior on engineering design decisions with specific examples drawn from personal vehicle design. Second, create a framework capable of optimizing realistic product portfolios with discrete and continuous variables when choices are made with complex consideration rules with thousands of rules per model. 3. Identify barriers and opportunities to compliance with United States fuel economy policy that relate to consideration behaviors. This research has led to 2 published papers. The first proposes an optimization framework that uses a consider then choose decision process. This overcomes discontinuities that are inherent in consideration models. The second paper demonstrates that consider then choose frameworks improve predicted error when compared to traditional compensatory choice model frameworks. Lastly, to support the aims of this grant, a workshop on complex choice behavior and transportation energy policy was held to build a dialogue between government officials, industry representatives, and academics. The participants in this workshop identified 3 areas of future transportation research. First, improving communication between all model stakeholders. Second, establishing universal model verification standards. And last, paying increased attention to foreign transportation markets.
Hello, my name is Kelly Gomez, and I am an undergraduate here at Stanford University working with Erin McDonald on the solar project. The focus of this project addresses the need for a more complete, inclusive adoption model of solar photovoltaic systems. A new dynamic framework modeling the interrelationships between industry, government, manufacturing, installers, and homeowners is needed to capture the many nonlinear factors that affect the estimated cost of the system and the price that is put forward to homeowners. The traditional decision-making agent is the homeowner, but a more complete model will also account for another decision-making agent that is frequently overlooked, the installer. In an agent-based model with two unique utility functions, these two agents will be defined more completely and be understood as following individual but complementary decision-making processes. They must interact at certain points in their decision-making in order to maximize the rate of adoption. From preliminary surveys that have been conducted and existing literature analysis, it has been seen that the primary interaction between the customer and the installer revolves around the economics of solar, and specific rhetoric regarding the economy of solar compared to traditional electricity utility affects many customers' decisions to adopt or not to adopt. One key external influence that falls under the policy umbrella is the effects of existing incentives. Currently, installers address the affordability of solar, incorporating the credits that will be received by state and federal governments directly into their rate analysis. However, a problem that has arisen is the exhaustion of state incentive programs due to saturation or the expiration of incentives like the Federal Incentive Tax Credit, or the ITC. These changes have not been widely modeled in the United States, nor have been seen and described from the installer side. Although incentives do not directly affect the installer, the manner in which they market their business and educate about solar may have to change, and this is something that will be incorporated into the agent-based model. Another key factor that will affect the utilities of each agent are soft costs. As stated previously, how installers frame the cost of solar affects how customers view and decide whether to adopt solar or not. However, the breakdown of soft costs is more granular than previously thought, and how certain soft cost processes, especially permitting and inspection, can be reduced may affect the overall price that the installer suggests to the customer. However, with variability in soft costs, installers have difficulty providing a hard and fast price tag to potential consumers. This uncertainty must be accounted for in the model. Thus, a granular cost model for solar is being built concurrently to define the profit partial utility of the installer. Ultimately, how the installer pitches solar to the homeowner and how the homeowner receives the information is a behavior that has not been modeled directly before and is one that will be captured in this new simulation. In summary, if estimated cost is higher, customers are more reluctant to adopt, which in turn negatively affects installers. Thus, an agent-based model is needed to better capture how incentives and soft costs affect the rate of adoption, because at a certain point, changes in incentives and soft costs will become irrelevant to solar adoption, and how installers will tailor their design and marketing models for customers will be an interesting outcome that our model will capture.